Hi. Today we are going to talk about what is directional deep brain stimulation. I have been given the task to talk about this next level of DBS programming, and we are going to cover up some of these questions down here. So, what I'm going to cover in my today's talk is just given here, and I'm going to jump into that, and we are going to look into what is there next in that. So when we talk about DBS, we know the standard programming, and now the question is what is directional deep brain stimulation and why does it even matter for us? As you can see in this image, which was published in the Neuroimage journal, you can notice that the DBS success is always a balance between the benefits and its side effects. That is, where the electrode is sitting and how it is stimulating that structure which we want to stimulate. And if you see this, you can see that there are four contacts. Only thing what we can move is up and down. That is along the Z axis or the Z axis. So the control is historically has been only in one plane, that is 1D, that is one vertical, what we are looking into it. So it has its own benefits, which was there, but it has its own limitations. What happens with the classical ring electrode, what we are using? The classical ring electrode, whenever a ring is, the electrode is utilized, it gives a circumferential current stimulation, which gives almost like a 360 degrees of stimulation is going on. So it works efficiently if the electrode is sitting in the center of that target, or the target is globular or round in structure, and because of that round structure, the stimulation happens in that area and you'll have a best benefit to get out of that. However, most of the time when you see it, most of the anatomical structures in the brain are not round or globular in nature. You can see this is an example which I have drawn down there, just how variable the structure. These anatomical structures can be anatomically variable and functionally also can be variable, how you want to utilize that. And in this, if you put the electrode stimulation, when you give it a circumferential stimulation, it may stimulate that and it may not be able to stimulate the whole structure the way we want to stimulate it. And the current will also spread over to the surrounding structures. And when it spreads over to the surrounding structures, which invariably happens to be more critical structures, we will start having effects related to those structures, which causes lot of unwanted so-called side effects, what we call it as. So this is a limitation what we look into it of the ring electrode. So we have a sweet spot where the electrode has to spin, and if the sweet and sour parts are equidistant, compromise is inevitable for us to manage. So basically we all knew this is not a thing. The problem wasn't a lack of stimulation. It was how to direct that current into the specified structure was always a question for us to go forward. So basically, what is this innovation? It is definitely not innovation. We all know that every structure is different, how the current works is different. It is just how we needed to reach that. Because we know that, as I pointed out, targets are non-spherical and every millimeter matters. So the question becomes, can we move the field and not the lead? Without the lead moving, can the electric field can be modified so that it stimulates the structure which we want to stimulate it? So that is how, welcome, we have the concept called as moving from rings to segments. So what does this tell? Look, the whole neurology, if you look into it, the concept of stimulation came from lesioning surgeries. The concept of lesioning surgeries came from the acute events what people had. People had stroke, people had brain injury, damaging certain brain structures. And when that damage happened, certain type of benefits or side effects people noticed. And people noted that if we can damage these structures intentionally, people can get benefit out of that. And somehow people thought that if lesioning can work, can we put an electric rod and see whether that can work? So, yes, it also worked. That's good. So that is how we moved from lesioning to stimulation. However, we also carried the side effects of those lesioning related effects. Because when we do a lesion, the lesion has to be in a specified area. If the lesion is not in a specified area, if it becomes a bigger lesion, touches other structure, you get side effects which cannot be undone. Whereas in stimulation, we can change the currents to manage it. However, now going forward, we have now understood that whether we can change the current fields itself. And hence, we are now moving from ring-based stimulations to contact-based, segmented contact, so that every part of the electrode can be utilized for a better stimulation of the structure. So what we have classically, there are different types of directional leads are available. People have produced from the rig leads. The classically what we commonly see is one contact is divided into three segments of 120 degrees each if you look into it. So it all acts to give a current in a certain direction of the lead which can be used. You also have contacts, electrodes with different levels of contacts, or even you have a quadri-segmented leads also. But remember that just having a directional lead is not equivalent to directional stimulation. It's just putting a lead there. But directional stimulation is whole process of what you are doing down there. So what does these leads which are there, what do they bring it? They bring a concept of new axis of control. Previously we had only single axis, that is the Z axis what we had. Now we have slight helpful modification in the X and Y plane. We can deviate the current thresholds and stimulate it in those directions to have it. So basically we didn't add more power. We added geometry to how the current spreads and people start getting benefit out of that. So does directionality will fix all the things for us? Because now we have a better geometry. We have gone from G plane to X, Y, Z, 3D dimension. Technically we have it. No. Directionality does not rescue poor targeting. Let us be fair enough. It does not eliminate disease progression related issues. It does not replace programming expertise. And if you have chosen the wrong patients, definitely does not going to help you out. So how does this directional stimulation works? Let us come more into more science of this. How does this work for us? So as I told you, it's not one single thing. It's whole shape what we are trying to work around that. So there are different ways to be directional. And the whole is we are using different techniques to create a different current field space which can fit into it, and using different technologies which different companies are implementing whichever model they can do it. I'm going to talk some of these which are well known: the single segment activation, two segment or multi-segment activation, some concept about steering and fractionalization, and anode blocking. So what is single segment activation? So if you see that if you have put the electrode and electrode is sitting, but it is sitting at the edge of the structure which you want to stimulate. Now it is stimulating your primary structure, and it is also stimulating the other unwanted structures which you didn't want to stimulate. So by using one segment of this, you are steering the current in one direction, that is towards your sweet spot, and not allowing less current to go into the unwanted spot. So by single segment activation, you are trying to manage it. You can see the example how it is done by switching off two other non-active contact, and the target area is much more covered if the stimulation is being managed like this. So this helps in maximal asymmetry, improve the smallest arm. It is default choice for first step in directional lead management or directional stimulation. Then if it works or if there is an issue, then you get the next step, because now you have used one segment, you can use two segments. So you can use two segments to have better coverage based upon where the lead is placed, or you can also go in the Z axis to go up and down so that a better area of stimulation can also be utilized. So it gives a more broader field with two segment and multi-segment activation, and sometimes it helps in better stability and coverages for us. With this single segment and multi-segment activation, I'll also just touch some aspect about current steering, because this is what the current steering. Now we are moving the whole field which was 360 degrees, which was working around there. We are now moving into single point of contact to have better steering. There is also another concept called as fractionization, where we decide how much current each contact is getting. So you can have the same current going in, but what strength of that current is reaching out to each of these contacts. And based upon that, the stimulation strength and the field modification will happen. For example, I have put a target structure down here, and this has to where if you can, the whole concept is we need to stimulate that target structure fully. This is an idealistic situation what we are looking into it. If the electrode is sitting that way, we need to have different contact working in a different way, different current strength, different directionality, so that most of this structure can be stimulated. And the fractionalization part helps into volume defining, so that it helps in a better current management and better modulation, which is available in some of the company models what we are having. Other concepts are interleaving and other things. Interleaving is before this, before the directionality came into the picture, which is there. I'm not going to touch a lot about it because the previous speakers have spoken about that. The next concept is anode blocking. So classically what we do, most of the case or the IPG works as a anode, and all the monopolar electrodes work as a cathode there, and we use there from where to use the current to be stimulated. Whenever we use cathodal stimulation, we are depolarizing and trigger action potential, blocking the signal transmission or deranging the signal transmission. Now, what is happening with the steering? Now you are able to steer it down to certain angle. Let us say you have switched off. Still, that therapeutic window is smaller. You want a smaller steering window with slightly higher potential. Then anode blocking will be one of the better ways to do it. What is happening? You are with the anode blocking around it. You are using the other segments as anodes, or the segments above and below as anodes, so that you are compressing your cathode signals transmission. This is the easiest and the simplest way I'm telling you for logical way of understanding. So anode is stimulating, let us say, cathode is pressing from all the directions, so that your beam becomes smaller or narrower down there where you can use it. So it helps in better field sculpting. So we know physiologically anode stimulation works in a different way. It targets different types of fibers in different way. But on a logical way, on day-to-day practice, this helps for us in better field steering. So anodic block in DBS refers to intentional or incidental hyperpolarization of axons near the anode, preventing signals propagation and contributing to therapeutic network modulation rather than simple excitation or inhibition. So we're helping to modulate. So this is another way of doing the directional steering. Even though all these things are there, it is not available in all the company models with all the aspects what I spoke about. Because these aspects are dependent upon lead design, IPZ architecture, which finally is going to decide which is the final field you are going to have. So directionality is system dependent. You should understand each one of these. Some of the models have better options. Some of them have better support or better technology. So you need to understand that what you are using and what type of options you are having down there. Once you understand what happens down there in the science behind the directionality, what you actually buy, why I should do it. So it is going to give you effect where there is a lower efficacy for threshold. Means therapeutic windows are smaller. You need to use whatever the smallest threshold is available for the best effect. This is where it will be utilized. And it tries to increase the higher side effect threshold. So you can go away from the more critical structures and utilize more stimulation related structures. Even though it is not universal, but it is reproducible. So in a simplest term to tell is directional DBS science when the ring DBS is almost working. That is what you should remember. And in day-to-day practice, the first slide, even though I told about the benefits, but the day-to-day practice, we always look most of the time from the side effect management. How to reduce if the electrode is spreading the current to the capsular effects, or if it is having lemniscal effects. How to reduce that? So to reduce this capsular spread, dysarthria, paresthesia, mood effects. This is where on a day-to-day practice, I have seen this is of mostly utilized if the lead is not sitting in the perfect sweet spot the way you wanted to sit it. Always remember, directionality helps in near miss in anatomy of the electrode where it is placing, but it does not justify the poor implantation. So having a good neurosurgeon is almost solves the need for the directionality most of the times. So if you have a good surgeon, you have decided a good choosing, good electrode replacement has happened, probably you may never need to come to this level of programming. There is always a concept. What we sell about the benefit is that probably you may need to use only a smaller contact, one contact, the energy utilization is less, so benefit could be there. Theoretically, yes, everything is feasible, but you need to see physics as a whole. Smaller contacts means higher impedances, and higher impedances means more utilization rates or more wear and tear. Uh, this is offsetted by lower amplitude. Most of the time it is required lower currents, lower amplitude is required. However, if you are steering it for a higher voltages, you have lost that energy saving concept. Even though we talk about this, the net effect is basically strategy. We are currently nowadays we're not worried about the battery life because we have long battery lives, what we are getting it. Our goal is to give the best benefit to the patient, what can be done. So what are the limitations and real world costs on this? The point is, we sell telling that it reduces time, everything, more options, more time. Let us be fair enough. Time burden is the most cited disadvantage. It's very clear. You ask most of the people because once you go from monopolar stimulation, if you are going to the next level of stimulation, always your time with the patient, with the programming will keep on increasing. That's the important thing what you should remember. Many people don't tell what are the some of the important because surgery is also critical thing. The lead, we are believing that the lead is placed the way it has to be placed and the directional contacts we know where they are. Many times when the placement is happening, if there's a lead rotation, sometimes on the imaging, the markers are not captured properly because of the technical issues what is happening there. And some of these things are imaging dependent. You have what you have seen and what you have marked are the one which is going to be captured. In simple words, what I can tell is directional DBS without orientation awareness is a good educated guesswork. So lot of things this goes at the time of surgery and post-surgery marking of those things to make sure that what you are looking at each contact, they are in the right place where otherwise you're doing a guesswork and managing on your programming aspects. Do remember directionality directly raises the bar. So optionally, it's less forgiving. You need to spend more time. People tell that it may be easier. You can quickly do around the things with different types of programming. A straightforward programming, usually you don't need to work around. But any patient who is going to go from step 1 to step 2, step 3 of the programming, if you had not documented the first assessments and subsequently whenever changes are being done, what changes, why they are being done, it becomes a pain. Always we can remember that for all DBS, when you are doing it's a long-term goal. You are not working for a short-term goal. Even though you spend some good quality time during the first assessment and programming, this documentation and professionalism is the keystone for management of DBS. This is very critical for you people to understand. If you do that, this helps you in long run. Don't worry about the time. The importance is long term. This time, what you spent on the first programming or the first initial assessments will help in long term for the management. So what are the evidences we are having and what are the consensus? Where does the directionality still? I think there is very clear-cut evidence is there where the proof of principle, I don't think when I told about the proof of principle, how it was, there is nothing to challenge here. All of us do agree how the directionality should work. And we have clearly seen that acute steering does give benefit. Whether it has have a long-term benefits is a question, but definitely it does work. And it's clearly the modulation is reproducible. However, Uncertainties are at the level of incremental benefits. It changes a smaller benefit from the issues what you had. It doesn't give the similar satisfaction how a perfectly placed a ring electrode would have given a benefit. That type of benefit you cannot expect with this thing. Yes, cost of surgery, cost of the leads do change. And always most important is optimal patient selection. If the patient selection has been poor, counseling has been poor, then amount of effort, whatever you put, will never be able to satisfy the goals what you have set for yourself or the patient has been set. So the final Kipling's questions: who, when, and how. Who benefits from directionally the most? These are the high yield groups. Patients with narrow therapeutic windows, directionality works to significantly improve your clinical outcomes. It helps in side effect limited stimulation. If the electrode is sitting just at the edge of the subthalamus and giving a capsular effect, you can manage that. It is just sitting more medially, giving more limbic effects. You can utilize it to target, to change it, the direction of the currents. And like targets, very fine targets, like the targets, thalamic target for the essential tremors. But targets which are very big, like the GPI, because GPI target itself is big enough, you need to have a whole structure to be stimulated. In those type of scenarios, having a directional lead may not be having much value at all because you want to have better stimulation. People with speech sensitive and STN patients, speech sensitive and STN patients can be better benefited down here. When does directionality adds little? When when directionality adds a very little. So it adds if you have wide therapeutic windows, probably directionality is not required. If the lead is perfectly placed, thank your surgeon a lot. So your job is also reduced. So definitely you will never go to directionality. And if people are having stable symptoms, not dramatically worsening, having new issues all the times, so then you probably may not be going to use directionality a lot. Finally, how to do or how to do the directional, or what is the pragmatic programming philosophy here? Always, just because you have put a directional lead does not mean that you need to jump to that. It's your backup. Your first important thing is your surgeon. Your surgeon having a good skill, and if you have made a right choice of patients, that sorts away all the problems. After that, you always start with a ring survey. If ring survey does give a good benefit, it works out everything. If the best level, whatever the ring survey is having a threshold limitation, then directionality can be used selectively. Then after that single segment activation, then you can go for escalate to other complexity only if needed. Just because you have the option to steer everything, please don't do that. You'll never be satisfied. Never, many times you may not be understand what is happening down there. So with this of understanding of directional deep brain stimulation, let us talk about some what things we may be having. Currently, what we are looking in the future is having more steering granularity, whether current controlled architecture can help us out, whether currently the sensing part, the local field potential sensing is not just part of this whole concept. It has to be done separately. Now, whether the sensing can be integrated down into it so that automated based changes can happen at this point. With this sensing integration, based upon this sensing integration, if current control architecture can be automatically modified, giving a better steering granularity, we'll be having an idealistic closed loop. But always remember, expertise will remain central. Always your skill, your decision will always be important. Please make sure you understand what you are doing. To take home, what I want to tell is many people I tell DBS is like a metronome. I know many of you heard about metronome in brain. The orchestra is running, but the orchestra is not doing good enough. You keep a metronome, it makes to feel that orchestra is slightly feeling better. However, Directional DBS makes it slightly more better. What it does, in classical DBS, it works as one loud metronome for the whole orchestra. For directional, it's like placing at one certain segment to work better. And what we don't have yet, a system that moves the metronome around the stage based upon where the noise is coming from. We can be reaching down there. This is what you need to understand. What is the role of the directional DBS is there. With this, I thank you. Thanks for the organizers for inviting me for this talk and whole team down here. Any questions, I'll be open to take following this. Thanks a lot.